AI is becoming increasingly powerful, but even the most advanced models struggle with complex tasks. But what if there was a simple trick to make AI systems up to 24% more effective, and it can stack on top of other strategies? This paper, More Agents is All You Need, reveals a powerful method to enhance LLM performance by using multiple agents in a clever way. We'll explore all the different implications of systems like this going mainstream. And to make this accessible to everyone, I spent hours developing a user-friendly tool that allows you to try the technology yourself. So how exactly does sampling and voting work? Essentially, you pose the same question to different instances of the same LLM. Then once they're done, they all come together and vote on the different outputs. How effective is this? As I said before, it can improve its answer by up to 24%. But here are the different benchmarks it was tested on. Something to note here is that the harder the task, more this method improved the system's performance. So the natural question is, can you just scale this up with no limit? And the answer is of course no. There is diminishing rate of return. The study seemed to do it up to 40 agents per prompt, but even 10 for some cases. So can it basically improve any kind of task? In short, yes, it seems like it. If you're not sure, I feel like it's something you can slap on any prompt and see what you get. But the caveat is the extra cost. There was another feature of this method that made it very, very ideal. It's the fact that it improves the response from cheaper models to levels where it beats standalone bigger models. Right now, the GPT 3.5 costs about $1.50 per million tokens, where the GPT-4 costs $30, which means you can make about 20 or so calls with GPT 3.5, and you'd still probably under 30. But if you want superior performance, you can even use this method with GPT-4 or Opus. The other important factor here is time. Generally speaking, these smaller models are faster, much faster. And the fact that you can run the samples concurrently means you might essentially be getting your results quicker. I did a quick little test, found that GPT-4 Turbo, the latest one from April 9th, did it about 20 seconds, and GPT 3.5 Turbo does it in 10. And the voting takes less than a second, so you're getting your answers faster for sure. Now you might be wondering, how does this voting process work? In step 1, we produce n samples. In step 2, for each sample, we calculate a cumulative score of how similar it is to every other sample. In essence, all other samples add a vote to the current sample, how similar they think they are. And the sample with the highest score is selected. Now here's an interesting question. Just because they voted on an answer doesn't actually mean it's the right answer, does it? No, it does not. However, it does increase its likelihood. There is no guarantee, but some added probability. Where this would benefit a lot of people, I think, is in areas such as healthcare, finance, and legal services, where accuracy of AI-generated output is crucial. As this kind of thing reduces hallucinations and makes the outputs more reliable and consistent, reducing the risk of errors and biased decisions. Instead of investing into a single large expensive model, organizations could invest into multiple cheap small models that work together. Speaking of reducing hallucinations, we know that RAG helps with reducing hallucinations. The great thing about this approach is that it can stack on top of RAG or chain of thought prompting or even multi-agent collaboration. These could potentially all boost the performance even more. As for limitations, the study finds that after about 40 samples, there's almost no improvements. But if you have the money, you can experiment with more and more samples, especially as the task gets more complicated. It seems like now there's a lot of different methods to get better outputs from AI systems. From fine-tuning foundational models to retrieval-augmented generation, to now sampling and voting to few-shot learning or chain-of-thought prompting or zero-shot prompting or multi-agent collaboration or building agents or increasing context, length and memory, or there's just asking your dad. Now another cool feature of this method is that it doesn't have to be destructive, meaning you could store all the samples and use it for other methods of improving performance. For example, you could have a large LLM like Gemini 1.5 Pro with its gargantuan context length, read all the responses and list all of the creative solutions, thereby creating a mini database of creative solutions. In general, these kinds of ensemble methods bring about new ways of thinking about integrating AI into organizations. Soon, there may be new fields, like AI-human interaction, just like computer-human interaction. We will have to figure out how best to insert human oversight or feedback into these systems, so that organizations can create more effective human-AI collaboration frameworks. The ensemble of LLM agents can generate diverse solutions, while human experts can select the most appropriate ones or provide guidance for further refinement. Well, that's it for today. Till tomorrow, keep experimenting.